In India, EEE has a certain reputation. Safe branch, old branch, the one you pick if you don't get computer science. Your family says it's a good choice, your uncle says it's evergreen. Everyone nods, nobody questions it. But here's what nobody tells you. Meet Tessy Thomas, electrical engineer from a small college in Kerala. Today she's known as the Missile Woman of India. She led the Agni-IV missile project at DRDO. Every long-range missile that India has developed, her team has developed the electrical systems inside. One EEE engineer from a college most Indians have never heard of, running a national defense program. That's EEE. In 2026, almost every big story in this country, every new electric car, every solar project, every chip factory, every ISRO satellite runs on what EEE engineers build. This old branch is actually running the new India, and most students pick it without even knowing that. So in the next 7 minutes, I want to show you 3 things. 1, what the EEE opportunity actually looks like in 2026, not promises, real numbers. 2, why most EEE graduates will still miss this opportunity, and it's not because they are not smart. And 3 specific things you must do from year 1 to actually catch these opportunities. Stay till the end, because the third thing is the most important thing which most 12th standard students will actually not do. And it's the one that matters most. Quick note before we get in, I'm Deepak, co-founder of Kaldyam, and we run a BTech computer science engineering program, not EEE. But here's the thing, I studied EEE myself. When I was 17, I picked this same branch. So this is not some outsider advice, this is something I wish I had known back then. And I'm not making this video to sell you anything. I'm making it because I have watched too many 17-year-olds pick this branch for the wrong reasons and miss everything that would have made this worth picking. Okay, let's look at the real numbers. 4 industries, all running on EEE. Electric vehicles. In 2026, India sold almost 2 lakh electric cars. That's up 83% in 1 year. Tata and Mahindra together own 61% of the market. The motor inside those cars, the charger, the controller, all designed by power electronics engineers, which is part of EEE. Solar energy. By March 2026, India crossed 150 gigawatts of solar. That's 55 gigawatts added in just 1 year, the biggest jump ever in Indian history. The panels are the easy part. The hard part is the systems that move the power from a farm in Rajasthan to the fan in your bedroom. And that again is EEE. Chip factories. India is spending around 8,000 crore rupees on the Mission Semiconductor 2.0. Tata's Dholera factory is coming online, 91,000 crores, 50,000 chips every month. Micron's Sanand unit, 22,500 crores. The engineers inside these factories, designing circuits, running electrical systems, EEE. Space and defense. ISRO, DRDO. In 2026, both are hiring electrical engineers. Every satellite, every missile, some electrical engineer is designing it. 4 industries all moving at the same time. This has never happened before. And this is not just talk. It is happening right now, and it's the biggest opportunity your generation will see. And to be honest, it did not look like this when I picked that branch. The opportunity you are looking at today is bigger than anything we had access to. Okay, now here's where it gets interesting. Open the job postings at Tesla India, Tata Electronics, ABB or Adani Group. You'll see one thing in common. None of them are hiring just electrical engineers. They are hiring power electronics designers, people who design the converter inside a EV, grid integration specialists, people who connect solar farms to the main power grid, embedded system engineers, people who program the computer inside electric cars, PCB designers who design circuit boards that actually work. All of them want the same kind of person. Not the student who can by heart hundreds of formulas for a semester exam, but the student who can actually build the hardware that will work. Practical skill, not exam skill. And this is where most EEE graduates fall incredibly short. This is the Anna University EEE syllabus, Regulation 2025, the latest version, 163 credits. The subjects look modern. There is full electric vehicle technology elective, battery management systems, smart grid, renewable energy, machine learning. Whoever made this list was paying attention. So what is the problem? The problem is how your time is split. The first 7 semesters where all the actual teaching happens, more than 60% of your classroom time is theory. Lectures, notes, formula on the blackboard and exam preparation. Less than 40% is hands-on work, and of that 40%, a big part is basic year 1 stuff. Physics labs, chemistry lab, computer programming lab, no EEE work. The actual time you spend building EEE things, soldering wires, designing circuits, testing a motor is a very small part of your degree. Here's one example. Semester 6 is supposed to be the most important EEE semester. Power electronics, microprocessor, electrical machine design, real hardware subjects. Open the timetable. Out of 28 weekly hours, 22 are lectures, 6 are labs. 79% of your most important EEE semester is classroom work. Only 21% is actually building. And then a Tata Electronics recruiter asks you to debug a electric circuit board. That is the gap. Now the other problem, internships. Look at the curriculum. There is only one summer internship in all of 4 years of the degree program. It sits in semester 7, 1 credit. That means for the first 3 years, 6 full semesters, there is no real company exposure. The degree expects you to prepare for the industry for 3 years without ever meeting the industry. Here's what nobody says out aloud. Your first industry exposure should ideally happen by the second year itself, not year 4. That is when the best hardware students all over the world are already working inside real companies. Unfortunately, the syllabus is not going to give you that. You will have to go and find that yourself on your own. And here's the deepest part of the tricky problem that nobody talks about. If you are a CSE student, the latest tools that the industry uses can be sitting right inside your laptop. The latest AI model, the latest GitHub library, the newest open source project, all of it free, online. A CSE student in a small college in Palakkad can have access to the same industrial tools that a Google engineer has on the same day. EEE is not like that. The newest battery management system Tesla designs, the chip design software Intel uses, the power electronics simulator at Tata Electronics, none of it is free, none of it is online. These tools cost lakhs of rupees, sometimes crores, and they live inside companies behind locked doors. The college cannot buy them, and even if it does, by the time they install it and design a syllabus around it, the industry has already moved on to the next thing. That is a EEE assignment. A CSE student can teach themselves the latest tools in 1 weekend. A EEE student cannot teach themselves a 3 crore semiconductor design tool from a YouTube video. The way out is actually getting into these companies which actually use them early, often, and any way you can. That's why the 3 things I'm going to give you now matter more for a EEE students than even for CSE students. So if you're 17 and about to choose EEE, what should you do? 3 things to be specific. 1. Pick a focus area and start now. The syllabus will not allow you to pick an elective till semester 5. So don't wait. Pick one direction today. EVs, solar, embedded systems, or power electronics. Read about it. Follow the companies on LinkedIn. Start playing with it at home. 4 years is too long to drift. 2. Start emailing for internships from year 2, not year 4. The curriculum will not give you a slot till semester 7. You do not need a slot. You need an email address and a loads of patience. In hardware, the best internships do not come from job portals. They come from referrals, and referrals come from relationships. A student who starts emailing from year 2 and follows up every few months would land an opportunity that a 4th year student may not even know that existed. 3. Build one real thing. Not 10 lab experiments, but one real thing in your chosen area. A working solar inverter, a motor controller for a small EV, a circuit board you designed from scratch, a small battery management prototype. One real thing that you built yourself matters more to that Tata Electronics recruiter than getting 10 grade A's in the lab subjects. Also, learn tools that companies actually use. MATLAB, Simulink, Healthy Spice, Altium, KiCad. Most college labs will not teach them properly. You have to learn them yourself online for free. The tools are often there, only the time and intention is missing. Honest disclosure, I did not do any of these 3 things when I was studying EEE. I followed the syllabus and I trusted that the curriculum would give me all that I needed. It did not, and I learned the hard way. So I am not giving you these 3 things from a textbook. I am giving it to you because I saw what happened to people who applied these things and what happened to those who did not. Take Saurav Kumar, electrical engineering graduate from IIT Delhi. In 2018, he started a company called Euler Motors. Today, Euler builds the electric 3-wheelers you see delivering packages in Indian cities. He did not wait for the perfect first job. He did not wait to finish his master's abroad. He started when he was young, and that is a pattern. One last honest thing. The 3 moves I gave you. Pick a direction, meet industry early, and build at least one real thing yourself. These are not just Kalvium ideas. They apply to any branch of engineering, especially hardware branches like EEE. Wherever you end up studying, these are your job, not anybody else's. So let me leave you with this. You probably walked in thinking EEE is safer than computer science engineering. A quieter branch, an old branch. Here's another way to see it. EEE is not safer, it's just different. It is what you pick when you want to build the physical things that run the AI economy. The cars that actually move, the power that actually reaches homes, the chips that actually exist. If you can picture yourself designing the motor inside a Tata EV, or the inverter on a rooftop solar system, or a circuit inside an ISRO satellite, this might be the most exciting branch in India right now. If you cannot picture that, choose something else. Scope is not a reason to pick any branch. And either way, the syllabus alone is not going to take you there. What you do with your 4 years, that will. And that is on you. All the best.